Hey everyone, let's get our hold music off there, eh? So, how is everyone doing this morning? This is a bit of a later start we had on Monday. I know, twice this week. We are streaming twice this week. I don't know if I'm punishing you or spoiling you, but yeah, we are back. Hope everybody's having a good day so far. I know this is a different time slot than we had on Monday, so I would love to hear people's thoughts on whether they prefer this slightly later slot or the slightly earlier time that we streamed on Monday. Obviously, Monday slot was a bit earlier for me. It was like 7:30 in the morning, but let's be honest, I have a 1-year-old. It's not like I was sleeping anyway. So I don't mind. I can do like this slot. I can do a bit earlier. I would love to hear people think what's better for you, what is more convenient, where you're tuning in from, what time it is for you, all that kind of stuff. But yeah, so what are we going to be working on today? So we started off on Monday. We were working on a new frame palette for our substrate-based blockchain. And our palette is, you know what? I should really kick off the AC here. You're going to get a lot of background noise. So I'm going to do that. 2 seconds. There we go. That should be better. I was like, why is it so loud in here? Yeah, I'm in a shed. I built this. Like, it's not quite impressive. Yeah, I built a little streaming studio for us at home, but it is in our shed in our backyard in Florida. And it gets pretty hot here, like pretty hot. So I have a fan and some AC, which helps a little bit. It's not insulated here, so it doesn't help that much. But it is super loud. So I do need to remember to turn that off before I stream normally. So sorry about that if you're getting a lot of background noise there. But yeah, so what was I saying? So we are working on a frame palette for managing projects, and we picked the projects one because it allows you to have kind of a lot of different things that we that are common amongst blockchains. So we're going to have some form of token, some way to pay a supplier for completing a project. We're also going to use multi-sig. So multi-sig is pretty cool because it allows us to have multiple people control a single account, but not all of them have to agree on an action being performed. So in this instance, we're going to have 3 people involved in our multi-sigs. We're going to have like the person requesting some work to be done. So the client, we're going to have the person completing the work, the provider, and we're going to have an adjudicator. An adjudicator's role is going to be if there's some disagreement between the client and the provider, that they will then step in. So like, say, for example, the client isn't satisfied that some work is being completed correctly, then they may ask that, like, they're not going to approve a payment for that milestone, and the provider then can ask the adjudicator to step in and to either make the payment or to make a partial payment or whatever else. They can decide from that point forward. So as part of that, we want to have some form of reward for the adjudicator as well. They're performing work here too. They have to be available to make those kind of decisions and things. So as part of that, then we're going to have, we finished off last time where we were setting some kind of like percentage off the fee should go to the adjudicator, so that we were going to, like, whatever the fee is for a milestone, they should get a certain percent off that. And we were also making decisions around, like, should the adjudicator still get paid if the project is canceled, for example, because it might not be their fault the project is canceled. They should probably still get their fee for it. But that's something we probably would want to set on a project basis. We had all these kind of things like in the project structure itself. And let's just bring up my screen so we can see what we were working on here. Okay, so this was like where we left off. We got this, there's our 3 different accounts that are going to be, these 3 are different people who are going to be involved in it. And this coffer is going to be our multi-sig account. Now, as far as our palette is concerned, it's just a regular account. we don't need to do anything special within our palette. We're going to be using the multi-sig palette, which will manage everything else for us. We just have these in here as like realistically to use the multi-sig. We just need this one. The reason we're also tracking like the client and provider adjudicator is so that we know who to pay different or who to transfer a different amount of token to. And then we added in this adjudicator reward, and like should they retain the reward if the project's canceled. So that's like our boolean there. Now we put this in as a %, and we started very briefly to talk about what we call safe math in Substrate. So I don't know how much you know about the way in which different architectures, processors, whatever, process math. But like if we say, for example, we've got like 100 of something and we divide it by 3, we all know we're going to get this 33.333 repeating. Okay. And depending upon like the different architecture that you have, the number of 3s here may differ, or the way in which it handles these floating point numbers could be different. You know, this what's really weird here is we go like, okay, so let's copy this answer, you know, and we do 3 and yeah, not very exact there. But what's really weird is we go like, oh, okay, so line 1, so the result of line 1, and let's do that times 3. And computers are weird. Anyway, as you can see, even in this one tiny example, it's not very consistent. So you can imagine in something like a blockchain, you know, where we need it to be deterministic, where we need like lots of disparate systems to come to consensus. We can't have even very small variations in how it handles floating point numbers and things like that. So having something in place where like, I should point out as well, I'm not going to give any kind of like financial investment advice on this. That's not what the stream is about. This is purely about like writing Rust, using Substrate, building palettes, all that kind of stuff. So don't waste your keystrokes and put that kind of stuff in chat because I'm not going to address it. Anyway, yeah, so where's gone. So anytime we got like a consensus system, we need everything to be deterministic. Doesn't matter what architecture it's on, doesn't matter where it's running. We need things to be exact. You know, it can't be a decimal point or whatever off, depending upon architecture. So that's why we have this concept of safe math. And one of the things that we have in SP runtime is like this %. You know, because if we were talking about like even going, okay, well, let's say our fee is 100 and we want to take like 30% of that. Oh, sorry, 33 or whatever, or a third, and blah, blah, blah. Yeah, of course, 30% of 100 is going to be 30 RN. It's going to work out pretty exact. What are we doing? There we go. Okay. Yeah, so we have some things that help us work out kind of percentages and stuff. And that's where we got to last time, is that we decided we're going to award a %, and we'd imported that from SP runtime. Okay, so that's where we kind of got to last time, is we now have our project. Oh, we started on a new function as well. We need to complete that. Somebody's sending hearts for Dr. Gavin Wood. Yeah, we all love Gavin right here. It's been so nice actually having him back in like that kind of engineering architect role. Like the guy is a machine. I get like because I do a lot of frame stuff at work. I always need to be really involved, or not involved. I need to keep up to speed with all of the changes that are happening in frame. You know, so I know kind of what's coming down the pipeline, what is different, what is changing, what needs to be documented, you know, what documentation needs to change, all that kind of stuff. So I get pinged every time there's a new like PR or new comments on things. You know, I'm subscribed to all of the issues in GitHub and everything else around kind of like Substrate and Frame, and it is constant. Like I am just flooded with notifications. Like Gavin and the rest of the core engineering team, they're incredible. Like the amount of work they put out, like it is it's a lot to keep up with. Check out Gavin's commit gas on GitHub if you get a chance. Like, yeah, the amount of work that guy puts in is just crazy. Okay, so yeah, we left off last time. We were just like creating this new function to make it easier for us to create projects. We'll probably do the same for our milestones as well. Let's just like remind ourselves of how these are structured. So we have our project, which is going to be stored. It's got like this title. It's got the different accounts you talked about. It's got the adjudicator stuff, and then it has this milestones, which is a collection of these milestone hashes, which is like the ID for a milestone. It has stuff like a status, whether it's complete, etc., etc. And a milestone then is going to be what's paid out on. Sasha's saying, yeah, it's so true. So many PRs every day. It is just a flood of them. I need a better way to manage my GitHub notifications if I'm being brutally honest. Like, it is so difficult to keep up with right now. If anybody got any hints or like good apps or stuff like that I can use for it, I would love it, because I hate email notifications. Like, they are awful, and I'm not a huge fan of GitHub's like built-in stuff. So I'm sure there's a better way of doing this. Like, people manage huge open source projects in GitHub, like probably tens of hundreds of notifications, if not more, per day. Like, I can't be the only person facing this problem. Somebody must have solved this already. Although one of my favorite kind of things about GitHub notifications that happened recently was that per guy, like, he was a kid. I think he was like maybe 18 or something. Made a trivial change to, I think, Unity. It was maybe like a documentation change or something, but like, I think in Unity, regardless of the scale of the change, you still can get added to the contributors list if you've got any PR kind of merged into it. And this kid, had a small documentation change to a README or something, added himself to the contributors, and was just like waiting for his PR to get merged. And I don't know if he was just super excited, but the prospect of being added to Unity contributor is like, yeah, I contributed to Unity. All my favorite games are beat on, or whatever. I don't know what his end game was or what he's trying to achieve. But after waiting, for a very short period of time, shall we say, he got a little bit impatient, and then tagged like all of the Unity organizations in his PR. And I think it sent out like, let's see if we can find the. I really want to look up the post about this now. It's like Unity GitHub notifications. Was there something about it? Somebody has to know about this, but it sent like millions of notifications. 400k users. There we go. But somebody was saying, like, so he sent a notification to like 400,000 users, and then of course, anytime anybody else that went and replied to that, it would send out another notification to like 400,000 people again. So it just became like the worst reply all kind of chain ever. So he's asking about validators not syncing, or is it just me? I'm sorry, Stateless. Again, this is just like a developer kind of one. If there's any kind of questions like that you have about current status or anything, it probably should go through like the actual correct channels for it. And if we look on so we've got the community stuff down here. We have everything from like the Discord to the element. There is a lot of different ways to get in contact with people who might be able to answer that question for you. I wouldn't have the information to answer the question right here. I wouldn't want to give any kind. I wouldn't want to hazard a guess or give any kind of incorrect information. I also don't know what the situation is with which particular validators you're talking about, etc. So yeah, I would keep those questions to like the correct channels, just because you're going to get more of a chance to speak to the people who will be able to provide you with accurate information, I would only be able to hazard a guess. So I'm not aware of what the situation is, or even if there is a situation. So I would go for the recommended channels for those kind of questions. Sasha saying reviews like crazy, all those labels. Yeah, me too. I need tips to manage notifications for GitHub team. Yeah. There's a lot of labels. I've not even noticed, like, let's go into Substrate. I think it might be under Parity tech. Here we go. Like when you get to the point where you have a repository for your labels. Like, this is crazy. This is how many labels that we have and different things that they have to do. That we have a repository for managing our labels. So like let's see if I can find where's the actual spec for it. The source maybe somewhere has there's actually a rules file. Where can I find our rules? Maybe this is just like the thing for parsing them. Maybe it's this one. Hey, here we go. Yeah, so we have actual rules for labels that have to be placed onto like PRs and stuff. Like using this ruled labels. Did we invent that, or is that like an open source thing? I'm not sure. But like we have these different rules, so require a single release B label. So we have like, I think it should tell us what Bs are. So every PR must have one of these two. It must have a B label. So like either silent or noteworthy. Release mentions need criticality. So if it's got a B1, which is a noteworthy, then it must also have some form of C, and C is like, low, medium, high, critical, whatever else. Like it is. There's a lot of rules around the labels that you need to put on PRs and issues and things as well. Like I'm gonna put this in here because I've not come across something like this in a company before. And it's impressive. Like it really, really is. And the fact that it's enforced like this is pretty cool. But it's also like when you think about it, like that's pretty nuts. Like we need this level of things because there's just so many PRs going out all the time just to help us kind of try and track it a little bit. Okay, so let's go back to your code. Okay, so we have, that's my editor. Right, so we have like the milestones, we have the projects, and I just started creating this like new function for things here as well. And then as I said, this is like, so Sasha's got like the full description of every contributing, detailing how to use the labels. Yeah, it's pretty cool. It seems like a lot of process, but it does really help things, especially with like a larger open source project with lots of contributors. Okay, so let's pull up some stuff here so we can kind of check where I was. Yeah, so you don't need to have these like new functions. You can just do it in like your extrinsic or whatever. I like to have them, especially if I have something like this that has some kind of defaults. So obviously things like these are not going to have a default because we need to be supplied for each project. And we could have things as well like, the adjudicator reward and the adjudicator retains reward. They could be optional. Like we could set a default value for these, and then if it's not supplied, we could, get it from the default value. We could make it as a configuration or something. Yeah, let's do that for this one. So we're gonna give them the option of passing that in, but we're gonna make it a option bool, and we'll if it's not supplied, we'll get it from the some like a default from somewhere. Either we'll store it as a on our runtime, or we'll just put it in our new function. We'll do something for it. What other things we kind of need to set? So the milestones is always going to be started as like empty. Created on, they're not going to get to set that because that's going to be just whatever the current block height is. And the status like everything probably is going to start as, what did we say our different statuses were, as pending, so not yet in progress. So those kind of things then we can do, right? So this is going to return, what's this going to return? It's going to return self. Yeah. And then, so title is just going to be title. We don't know anything else with that, do we? Same for coffer. Oh, we need to tell it like what we're returning here. We are going to be returning a project struct. Okay, now we can do like title, coffer. What we got? Title, coffer, client, provider, adjudicator. Okay. So this is going to be our option here. So we're going to do adjudicator retains reward. And that's going to be this. We're going to do an unwrap or. So we're just going to set our default in there. The adjudicator reward, we probably should set that. Like, let's just have them pass that in. Yeah. That's going to be our percent. Capital P, doesn't it? Yeah, there we go. So we'll just give an adjudicator reward in here as well. What else we have then? We talked about, we have milestones. So milestones is just going to be like the default. Default. Yeah, like that. What else we have? We got our created on. So this is going to be our block height. And we can get that from the frame system. Palette. Generic T. And then it is block number. Okay, that should give us the current block height. And status is going to be status pending. That's what we decided, wasn't it? Hey, why are you underlined? Oh, it's just Rust Analyzer is catching up. Give it a second, it should be fine. Okay, so I think that's everything we need for this one. Hey, hello again. Good to see you, Jafar. Okay, so that's going to turn on new project. Great. Should we do the same thing for milestone? Yeah, let's do the same thing for milestone. Okay, so we're going to do nope, not an import. It's going to be that p config. This time it's going to be our milestone. Okay, and what we got to do? New. It's going to return self as well. All right, and this one, what do we need? So we're going to have them set the ID, which we said was going to be this milestone hash. And we're going to need a title, which was this thing. And fee, which is a balance off. What else? Those ones we don't need to set. On that we don't need to set because we're gonna provide the values for those. So that's like not something that we need to worry about putting in here. Yeah, so we can then so that's going to be linked to I'm just gonna like work out my head here. So we have a milestone. Milestone's gonna be added to a project. From the milestone, then we'll be able to look up the projects in based on this. Should it also have a reference to the project itself? I'm wondering. So it's easy to get from a milestone to a project as well, from a project to a milestone, without having to like, query into these. for a particular thing, you know, like, what are we going to store these in reference to? So we think of like our different storages that we have in Substrate, you know, so we have, let's just go look up the documentation for it. Right, so Substrate storages. Oh yeah, are we going to get decoded? Who's all going? Who in chat's going to the decoded in like what, a week? We're not far off. Yeah, I'm actually going to be leaving not this Sunday, but next Sunday. So I'll be there a little bit early. Because I'm going to be there for the 2 days ahead of Decoded, where we are going to be having our ecosystem summit. So I will actually be there for 4 days, not just the 2 for Decoded, but 2 before it as well. Who all from anybody in chat going to be there too? Hopefully some folks are going to be there. I think it's going to be a lot of fun. I'm really looking forward to going back to Copenhagen. I've not been there for a while. It's a beautiful city. I'm not sure what the what the weather's going to be like this time of year, though. I'm used to Florida's heat, so I'm thinking even in June, excuse me, even in June, like Copenhagen is probably going to be pretty cold, which is weird for me to say. Like, I'm freaking Ireland. I spent 16 years in Scotland. You know, 18 degrees used to be shorts and go to the park weather. Now 18 degrees and I'm like rubbing my hands together and blowing on them. It's that cold. But yeah, I think Copenhagen is going to be pretty chilly to my Florida climatized person now. But I'm still really looking forward to it. I think it's going to be a wonderful event. You know, we've got so much stuff going on. I'm just like looking at all the photos to see who I recognize. You know, we have a bunch of panels, we have a bunch of stages. I'm going to be streaming from there. So is Sasha, who we've seen put in a few comments from today already. Sasha's going to be there. He's going to be streaming too. So we're going to be like live on this channel from Decoded. So that's going to be a lot of fun. If you're going to the conference and you want to come on stream with us, you know, like if you're from one of the parachains or another ecosystem project, you want to come on the stream and talk about it, like let me know. You know, we're gonna be there, as I said, throughout the 2 days, and you know, we're more than happy to get you on. Come talk about your project. Let the community know about it. So yeah, either like pop something in chat now, or you know, send me a message on Twitter or any of the other things we talked about. You know, we've got all of our different ways of getting in touch down here. It's just like send us a message, let us know, and either come chat with me or Sasha, or I think Lauren's going to be streaming as well. You know, so we have plenty of people you can come chat with at Decoded. But yeah, so I'm very excited about that. But let's get back to the runtime structures. So we are going to be storing these projects, and I'm thinking we're probably going to store them in one of the maps. So we have storage value, which is just like a regular variable. Oh, okay. So it's like 9 o'clock in the morning for me, or just after, and it, like, I know hot water is non-alcoholic, and that's kind of fine, like drinking this in the morning. We also, in our fridge, we have a bunch of non-alcoholic beers and like mocktails, you know, like non-alcoholic cocktails. I'm like pulling out of water this morning. I'm like, I know it's 9 o'clock in the morning, and these are non-alcoholic. They're essentially just flavored water. Why does it still feel weird to drink one? Anyway, that's some kind of weird hang up I have. But moving on, Sasha saying yes. Let us know. So this is about the Decoded. If you want to come on stream, we do have the Substrate seminars repo. You can drop an issue in there. You know, there's lots of different ways of getting in touch with us. So yeah, really looking forward to getting the stream going from Decoded. Looking forward to chatting to a lot of people from the community, getting them on stream. That's really what we're doing it for, is just a chance for people to come on and kind of promote what they're working on and like interesting things that the community might want to hear about. But yeah, going back to the storage stuff. So Probably going to store it in a storage map. So storage map is, so you got a key and you got a value. So the value is going to be our project, this struct that we've created here. This is what our value is going to be. But what should that be stored under? Like what should our key be for it? It needs to be something unique. So I'm thinking maybe like the coffer, So that's the multi-sig account for this project. And we could just say that like each project requires a unique multi-sig account, like a unique coffer, a unique pot to pay it from. Because we're going to be like assigning parts of the balance in this coffer to pay for each milestone. So it kind of makes sense that like anything free balance wise that's available in here should only be to pay for this project. So I think we can probably make this our key, which means our milestone should probably have a reference to this as well. Because right now we can very easily, if we've got a project, so we pull this project out of storage, we can very easily get all of the milestones because we're going to store the milestones under this ID. We'll use that as their key. So we can iterate over this collection and find these really easily in our storage. But if we've got a milestone, at the moment, we don't really have an easy way to go back to a project. We can't query into this in our storage. If we're doing like a get on a storage item, we're doing a get by the key. We can't do the get by something in a collection inside of the value of our storage. There's no way for us to do like, in our project storage, let's look inside milestones, inside this bounded vector for a particular hash and see if it exists. Like we can't do that kind of query. So what we would have to do if we didn't have some way of referencing the project to the milestone is literally grab every single project and iterate over them until we find one that had this hash within this collection. And that's horribly inefficient. We really don't want to be doing something as inefficient as that within our blockchain. We have 6 seconds block authoring time to work with here, and we got to do everything within that. Not just this one transaction or whatever. Like that's for like offering the entire block. So we want to try and keep things as efficient as possible. So yeah, we're going to be duplicating a little bit of data here by adding in, we're just going to like pop this in here as well. Okay. Yeah, so we're tracking this in a couple different places now, and that is going to increase the amount of storage that we require, but that's going to be minuscule compared to the performance hit required to look up a project based on a milestone. Otherwise, having to iterate through every single project potentially in our entire blockchain, trying to find a particular milestone hash is going to be like a lot more computationally expensive than just storing the account ID on the milestone. So now if we've got a milestone, we'll have this account ID, and if we use this account ID as the storage key for our project, then it's one query. That makes sense? Hi, Simply Mateus. Hey. Good to see you. Thank you for joining us on the stream. But yeah, hopefully that makes sense then. That like that's gonna gives us kind of this two-way reference between it. We've got like our collection of all our milestones, and on our milestone we've got a reference to the key for the project. So we're gonna need to put that in here as well. After title, we're also gonna need our account ID. We'll drop that in there. Does this need anything else? That's going to be automatically set. That's going to be automatically set. That's going to be automatically set. Nope. I think we're all good. So now we can do, let's just return our milestone. Don't do that. Why is it trying to complete this for me? That's not what I wanted at all. Is it? No, it's not. Why are you putting all of these in as like? Wow, that was a really dumb autocomplete. I mean ID, title, coffer, be created on. How does Polkadot relay chain handle transactions that would surpass the 6-second block time execution? That is a very good question. I'm not sure of the actual like how that, if it would time out or what the actual process would be for that. I know really for anything that is likely to exceed it, you probably want to have an off-chain worker. So it's not bounded by the same kind of issues. I've not come across a situation before where we've exceeded that block execution time. I don't know if it would actually just fail or if it would like just mean that you're not able to author blocks as quickly as you should. I need to look that up, to be honest. I'm not sure where in the documentation that would be, but I will find out before the next stream and I will have an answer for you on that stream, because that is a very important question, is like what would actually happen if we were to, would it just stall our chain completely? Would the, like, is it extrinsic itself just fail? Would we not be able to author that block? Or would it just wait until that execution has completed and it would just extend our block authoring time for that particular one? Honestly, unsure. These are just like situations that I think if I may handle it, I need to go look it up, but I will look it up before our next stream, so I know the answer to that, because that is a very important thing to know. I do know though, if it was coming out of a situation, I would probably look at some kind of like off-chain worker for it. We're not going to run into it here. Don't worry. We're going to be very efficient. I hope. And we're going to spell created on correctly. Right. So that's going to be the same as I have down here, which is this. So I can just copy that up, bump. And because it's going to be like the first time or updated and are created on, it's going to be the same. The reason I'm putting these in as well, you know, why am I tracking when it was created on or when it was updated on or anything like that, is I'm thinking as we get further into this, we may want to have some way of tracking like a project that's stale. Oh, hey, Sasha has the answers for us by the looks of it. Basically, a transaction pool is a runtime API to check the weights, and a block author will make sure it doesn't include transactions that would exceed the weight capacity of a single block. Okay, so it's all down to making sure our weights are set correctly. So that means that probably benchmarking is pretty important. I'm going to assume on that one, Sasha, then to make sure that, you know, we have our weight set correctly so that we kind of can estimate exactly how many transactions we can put in of a certain weight, and before we're likely to exceed that block authoring time. Is that sound about right? I'm sure there's probably situations though where things could go wrong, you know, where something could be held up, either a weight is set incorrectly, or, you know, somebody hasn't thought about the size of a storage correctly, or there's some other kind of, you know, latency being introduced, either, you know, IO or whatever else, that means you're going to exceed that 6 seconds. I would love to know what happens in that situation, you know, where you haven't planned, like the author has pulled transactions from the pool that it thinks it can fit within the block authoring time, and it ends up exceeding it. Does that author then miss out on authoring that block? You know, is it handed off to somebody else, or are they punished for it, or is it just like allowed to go through? These are all kind of questions that I probably should find out the answer to. So I will double check that and figure out as well. Okay, so where do we get to? We got updated on and status. We're gonna do the same thing again. Status pending. Oh, we were talking about what we need all these block numbers for. That was the other thing I was talking about here. So where are you shouting at me? What's wrong with the title? Oh, it's just Rust Analyzers catching up. It's fine. Oh, Sash is saying no, let's be put back in the queue so long as it's still a valid transaction. And we got somebody saying, so for example, a transaction execution of 0.0001 from a parachain to make the blockage time exceed 6 seconds would push that transaction to the next block. No, don't be sorry about it being off topic. Like this is perfectly on topic. You know, this is all about kind of substrate blockchain development. Like I'm more than happy to take these kind of questions. It's something I'm really interested in answering too. I'm so glad Sasha's here to help us with these kind of questions too. From what I'm gathering, it sounds like that would be the case, you know. So like if it looks like a transaction is going to push us over that block offering time, it just won't. It'll go back into the queue. It'll sit in that transaction pool waiting for another chance to be added into a block. Hopefully, Nuno's enjoying the conversation too. So yeah, definitely not off topic. Like this is actually really interesting. Let me see if Sasha's got any more reply. But while he's doing that, we'll talk a little bit more about why I'm putting these in. As I see kind of down to as well, making sure that, you know, we're being respectful of kind of storages and our people running our different nodes and things, because we don't want to have storage items just hanging around indefinitely, you know. So yes, we do have an account that will have some number of tokens in it, but those tokens are there to pay for these milestones. You know, it's not there to pay indefinitely for storage or anything like that. Yeah, they'll pay a fee during the transaction as we add stuff into storage, but we don't want somebody creating, you know, a project which is going to start off as pending, for example, and then just like never adding new milestones to it or never topping up the coffer or whatever else, and it just kind of like sitting in there and using up storage and not actually being doing anything with. Or for the same example, you know, they could add a little bit into the multi-sig account, add some milestones, and then again it just sits there and never gets worked on and is steel. I mean, we've all been on we've all worked on this project before, I'm sure. You know, you set up for the best of intentions and then something happens and either the project itself stalls or you know, it gets sidelined, backlogged, whatever you want to call it. And we don't want that to just be hanging about forever in our chain state. And we want to give people an incentive to, you know, to either to cancel it, because we're going to have this like canceled. And once a project has been canceled, then we'll be able to do some like house cleaning, and you'll be able to remove it from the storage and stuff afterwards. So we'll do that like in a hook and things, and we'll look at that later on in development. But like we do have ways in which the project can be completed or it can be canceled. And we should really ensure that people are using those as well. Like we don't want them just like leaving a project there indefinitely. So what we'll have is probably, you know, if a project has not been modified in X number of blocks, you know, we'll decide upon what that number should be later on. You know, but the project been setting steel for, you know, whatever number of blocks you want to say, or, you know, for whatever number of blocks equal to like 6 months or 3 months or whatever we decide upon. We'll probably make it configurable as part of our runtime. Then we probably want people to be able to mark it as abandoned, you know, or mark it as steel or something. And we could even have it that like they get a payment out of whatever tokens is currently in that pot to pay for the milestones. You know, if somebody abandons a project and another user finds an abandoned project, then they can get some kind of reward for helping keep the chain state tidy. You know, we've got lots of different options around that. So that's why I'm kind of putting these in here now. So we'll have those. Okay, so we've got our milestones. We've got our project. I think that's all of the structs that we need. So now we can actually like put them into storage So we've talked about kind of like how we would structure the storage. And it's not just like actually add them in. So we're going to put them, they need to be within our, are they within our config? Yep, they are within here. Or sorry, not within our config, within our, right, so you got palette. And our palette storages then need to be within there. Yeah. So we are going to just add them after these structs we defined for it. So let's do the milestone first. So we need to our macro. It's going to be our palette storage macro. Now, we do have another thing that we could add in here, which is our getters. Maybe people have seen these before, where you can specify a palette, getter, and then give it like a function name. It'd be like milestones or something, and it gives you like a slightly shorthand way of doing gets on the storage. I would really advise not putting these in right now because they're being deprecated. So little heads up on that one. I don't think it's been removed just yet. I think in the latest version of Substrate, it should give you a warning if you're still using those macros. But yeah, they're going to be removed in future versions. So anything new you're writing, I wouldn't add them in. And if you're going back in to refactor any of your palettes, probably a good time to start thinking about removing those as well, because they are going to be removed from Substrate. There's a PR for it. But yeah, as we talked about earlier on, there's so many PRs, it can be easy to miss some, but that's just one that I've seen, is that those storages are, the getters for storages are gonna come out. And honestly, they really didn't add an awful lot to be for the maintenance burden that you get from them. There's not an awful lot of utility. See if you like a couple of keystrokes. Yeah. Not worth it. So where are we at? Okay. We are going to add in our storages, and we're not going to use our getter. And this is going to be our milestones. No, project. We're right underneath projects. Let's just do projects first. So projects is going to our tconfig again. I'm very say we're going to make this a type of storage map. We're fine with the regular prefix. And okay, so let's talk a little bit about like what I'm doing here as I'm kind of filling it in. Or let's fill it in first, and we'll go back and talk about what all of these different options are that I'm putting in here. I think that should be everything. Yeah, okay. Right. So we are, for our projects, we are going to be creating a storage map. So it's one of the different kind of storage primitives that we have in Substrate. I'm doing a huge amount of work documenting all the different storages that we have right now, and there's a lot. Like when you look at the documentation for it, it doesn't seem like we have that many. Storage value, storage map, storage L map, storage M map. That's actually missing one. We have a counted storage map in there as well. Each of these storage maps also have like iterable storages attached to it, and they have like storage info and oh, we got a question here. How can we encode structs like project or milestone in custom RPC that contains tconfig? RPC call. I tried to do a passing a function argument return type, but I couldn't. So are we talking like through Poker.js, or like what do you mean in this context, Avrit? Because like if you're talking about defining it in our Rust code, like for a storage, like I'm doing it right here. So here I'm saying like projects over a generic tconfig, and then I'm passing in that generic t here. But are you talking about like an RPC call coming from what in JS, so Polka.js. I've never had an issue with it, to be honest. Like I've never had to. I'm not a huge front end person. So anytime I'm using the front end for interacting with anything, I'm using Polka.js as kind of built-in one, and like this is gonna be seriously broken if I try to run it right now. So I can't even go and like look at Polka.js's front end to give you an example at the moment. What could I do to bring up to get so we can have a look at this? Because it handles it all for you. So I'm not too sure like when you would need to be doing it manually. Because it should be to pull the meta information from it and be able to prepare it all for you itself. Like I've never had to manually put together an RPC call. Like it's just taken care of it for me, done all the encoding and everything else. Like obviously JavaScript doesn't have the same native types as Rust does, and it definitely is not going to have like things like any of our custom types. It's not going to know what a config is, for example. But as far as I'm aware, whenever you're connecting via like Polka.js to a substrate-based chain, it's providing all of the meta information back to it. And part of that meta information is how to represent these different elements in JavaScript so they can be properly encoded as an RPC call to be sent to our chain. So that there's a whole big thing that happens as part of that encoding as well. It's not just about knowing the type. It's also got to be like scale encoded. People are not aware of what scale is. This is our type encoding. So anything that's being sent is like calls is all being scale encoded. And there's a lot more documentation in here about like kind of the scale codec, etc. And that's all being handled for you if you're using something like Polka.js. I'm not sure about its internals of how it gets the metadata is provided from Substrate as far as I'm aware to Polka.js, which part of that metadata is also how you would represent each of the types required for a particular call within JavaScript. Polka.js takes that meta information and then uses that to put together the encoded calls. How it does that construction, I've never delved that deeply into the internals of Polka.js to tell you that. I just know the overarching kind of process that it's going through. But yeah, for that kind of level of question, I would look at Polka.js is probably either its own documentation or probably even delve into the code, look for where it's getting the meta information from the substrate-based chain and how it's doing that encoding, how it's being represented in JavaScript for custom types. And that then could help you probably if you're doing some kind of custom RPC calls that are not going through Polka.js. You can probably follow something very similar to how they're doing it to construct it. Another interesting way, so as part of PBA, so PBA is the Polkadot Blockchain Academy. Let's go look that up. For anybody who has never heard of it before, there we go, Polkadot Blockchain Academy. So twice a year we run this academy, all about blockchain development, Polkadot ecosystem, etc. I was fortunate enough to be in the cohort that was in Buenos Aires back at the start of the year. I'm also going to be in Berkeley this summer in July, where I'm going to be returning to the academy, but this time not as a student. I'm going to be there helping with the Substrate, Frame, and Smart Contracts modules. I'll also be there as part of the Founders track. So if you are thinking about starting your own parachain, you're a CTO looking for some technical founders or whatever else, you've got an idea for a chain, I will be there holding office hours and giving you some more background information on how everything works and how the whole ecosystem comes together and how things work in conjunction with each other. I'm just basically, free to chat, and we'll probably grab dinner some nights and things like that. But yeah, I will be there as kind of teaching assistant and support for the students and helping them with assignments and et cetera, et cetera, et cetera. But anyway, back to why I brought up Blockchain Academy. As one of the assignments that we were given in Buenos Aires is that we had to build a frameless chain. So essentially, what we're talking about here with frame and palettes and all the stuff that we've been coding. Oh, you're going to be attending PBA as a student. That's awesome. Yeah, I will be there weeks. Oh gosh, I think weeks 2, 3, and 4, or 3, 4, and 5, whatever the last 3 weeks are. I will be there for those. I'm going to be teaching for 2 weeks. So I'm going to be there for the smart contracts, the frame, and the substrate modules, where I will be one of your TAs. So I'll be there to help you with assignments and answering questions during class and all that kind of stuff. And then I'm also going to hang about for like the final week, just because I want to see you all graduate. The graduation was really, really fun, actually, and I had a great time. I'm gonna just like bring up my phone here because I want to flex a little bit. Let me see if I can get it up. Come on. Why will this not change? There we go. So this is my kid and my wife, who's also at PBA and also graduated as well. Oh, light up. And that is after our graduation. So yeah, my kid walked across with my wife. So that was a really, really fun time for me. So I'm going to hang about for the following week to see all the next cohort of students graduate as well. So that's going to be interesting. So yeah, can't wait to meet you there, Snowmaiden. But one of the assignments that we had, and I'm sure you may have the same one, it may be different, so don't take this as like, don't start preparing this now, because they do change each cohort. They try and improve upon it. Things are a little bit different each time because I was the one I was in was the second ever cohort. That's gonna be the third ever cohort, so still a very new program. They're constantly making kind of changes and adjustments to it, etc. But one of the assignments we had was to create a frameless blockchain. So still using Substrate, but we were dropping out all of the frame stuff, which meant for things like making RPC calls. Well, we couldn't use Polka.js because Polka.js kind of makes assumptions about how your blockchain is going to behave. And while we were using the guts of Substrate, it was a very cut down version that didn't include frame, and we were obviously making our own butchered version of it, which was not returning things like the metadata that Polka.js needs to in order to encode the calls to send. So part of the assignment was that we also had to have like a front end for it. Can some grant support provider PBA for staying there? I'm from India. I can have a funding problem. It is free. Like, it's not that you need a grant or anything like that. All of your accommodation is covered. Like, okay, so this one's closed, unfortunately. We're gonna be running them twice a year though. But like, I think it probably says in here somewhere. That's curriculum, teaching. How much does it cost? There we go. Accommodation and most food costs are covered for those who are offered a place. So the only thing that you need to really pay for yourself, Everett, is getting to wherever the academy is being held. So that this time around it's going to be in Berkeley, California. Cohort I was in Buenos Aires in Argentina. Cohort before that was in Cambridge in England. I think the next one we're probably going to go to somewhere in Asia. Don't hold me to that. Okay, I said these things are all in flux. But that is the direction I think that we're looking at the moment, is going somewhere in Asia. So, and it's free, so all you need to do really is cover your cost of getting to the academy, all your accommodation. So you're put up in like a hotel or on campus or something like that for the duration. Breakfast is all provided, lunch is all provided. I think the only things that weren't provided was evening meals. So if you're going out for dinner or something like that, that's kind of like you pay for that yourself. But there's also a bunch of side events as well that were all catered. So I think each week there was probably 2 or 3 side events, and each of those was was catering and open bar and drinks and et cetera, et cetera. So really, you didn't need an awful lot of funding in order to attend. Most of it was provided for you. The big problem for some people, and I do have to kind of highlight this, is it is like a 5-week long program, and it is full time. I would start my day at 8 o'clock in the morning. We'd have to leave to get to class, and some days class wouldn't finish till 6 or 7 o'clock at night, and then you would have assignments after that. So like I would sometimes find myself working till 2 o'clock in the morning. I'm old. So I was going to bed early compared to some of the students. Like some of them, were pulling all-nighters and treating it like hackathons and, working all weekend. I can't do that kind of thing anymore. Also, I had my child with me, as you saw from the photo there. Like he would have been like 6 months, 7 months at that point. And a 7-month-old doesn't care that dad didn't go to bed till 3 o'clock in the morning. Like he's still waking up at 4 for a feed, and he's still waking up at like 7, so I couldn't do the all-nighters like some of the other students did. But it is a pretty intense course, and it is 5 weeks long. So like you cannot be doing anything else during that time. Like, and that's the hard part, I feel, is trying to find 5 weeks so you can just like take off from work, take off from like the rest of your responsibilities. So yeah, we do try to provide as much as we can in regards to, there's no tuition fees, there's no accommodation fees. Most of your food costs and things are covered. But yeah, the one thing that we can't provide for you is any more time. It is an in-person thing. It is full-time. So yeah, getting the time off work and stuff like that can be difficult for folks, and I do want to acknowledge that. It was interesting in Argentina because apparently they have a like law there that your employer has to give you a certain amount of time off per year for education, as long as it's relevant to your employment. It doesn't have to be paid, but they also like can't stop you from taking it. They have to make alliances for it. So we had a lot of people at the Buenos Aires one from Argentina who were like taking that kind of unpaid sabbatical from work to attend, etc. Luke is asking, what is special about Rust? So I wasn't a Rust developer before I started at Parity, before I started working with Polkadot and the ecosystem. I was a Python developer, and I was really heavily into the Python ecosystem. Like I'm still wearing a DjangoCon shirt. I'm on the DSF board, which is the Django Software Foundation. I was vice president of the foundation for a while. I'm still a board member there. I've been on the board for DEFNA, which is the Django Events Foundation for North America that organizes DjangoCon. I have spoke probably, I don't know, in excess of 50, 60 times at Python conferences. That's why I wasn't streaming the last couple weeks, because I was at PyCon Italy, where I was giving a talk, and I was also attending DjangoCon Europe. So like I was very heavily in the Python ecosystem. I was a Python developer. I'm still pretty heavily in the Python ecosystem. A lot of my network and my friends and everything is still there. So why am I not writing Rust? Honestly, part of it is because of where I work now. Like that there's no denying that. Like that was the incentive for me to move to Rust. I'd heard a lot about Rust. I had a lot of people I talked to in the ecosystem, people I really respected in the Python ecosystem, were moving to Rust, and they had really great things to say about it's package management, or the compiler, and how it stopped you from interesting bugs, etc. But didn't really have much of a reason to change at that point. Yes, Python's package management has problems, but they're known problems. I've been working with it for so long now that I know what the issues are and I know how to work around them. And types, yeah, people talk about like the Rust compiler and how it makes it easier to write codes and bug-free code, etc. But I use type ending in Python. I thought that was enough, So I never really had a reason to change until I get into parity, and then started learning Rust. And honestly, I'm really enjoying it. Like, yes, the tooling is fantastic. There's no getting around that. I've not run into anything yet in Cargo that I've been like, I don't like the way it does this, or it's missing this feature. Like installing packages. I can install packages from obviously like from the repository. I can install packages from Git. I can install packages from a local directory. I can install packages, like it's all built in, and there's no weird flags or things like that I need to set like I do for pip. It's so straightforward to the package management and the flexibility that it gives you. And the fact as well that, so if I say for example, Substrate, if we look at, let's go look at Substrate's GitHub here. So you can see exactly what I'm talking about. If we go look, let's go look at any of these. Okay, so here we go. So we have in our dependencies list here, so we are within Substrate, and we've got our cargo toml for just a random palette, and you can see it is using path to install all these dependencies. So here's the different palettes, SPIO, and we're just giving it a path because this is still within the same repository. It can go up, it can go into like different directory and install from there. If you go look at my code, and cargo.toml, and we've got like SPIO, same package. Oh, look, I can just put in the Git address. There's and I can tell which branch I want to install from. I can tell what version I'm looking for, and it'll just go and install it. Like there's no mucking about with giving it different flags or anything like that we are used to in kind of pip and things. And also I get my lock files. So lock files are built in. Like none of this pip freeze nonsense that we have to use. Like, again, these are all things that are not kind of built in Python. Like, yes, there's tools to manage it. We can use poetry. We can use pip tools. And I have ways that I've figured out. Like, there's a talk I give in I think back in like 2016. Yeah, so this is like 2016. I give this talk at PyCon UK, about how to manage your pip install process. Very little has changed since then, about how I would do things in Python. I might now use poetry for some things. I probably wouldn't use a requirements.in file. I would now use like the PyProject file for defining my top level dependencies. But beyond that, it's still pretty much the same. Not a lot has changed in the Python ecosystem in the last 7 years. That's a good thing and a bad thing. It's a good thing in that kind of points to maybe the fact that we've started to solve some of these dependency problems. It's a bad thing in that we know there was still a lot of deficiencies in it. And I am not pointing any fingers here at all. The people running PyPI are doing an incredible job with very, very, very limited amount of resources. Like if people knew how limited the resources were, that is running such a key part of the world's infrastructure. Let's not, like, we can't underplay this. Okay, like PyPI is for people who do know what PyPI is. It's the Python package index. It's where all the Python packages, if you run like a pip install, if you're doing your dependency management in Python, it's probably where they're going to get installed from. Part of this talk that I give is about how you can also run your own local version of PyPI for whenever, package, if it goes down or packages or disappear or whatever else, it's all in there. But for the most part, if you're going to be installing something in Python, you're going to be installing it from PyPI. And it is, like, as far as I'm aware, 2 people. Used to be 1 person working part-time who managed that entire thing. And you think of, like, how critical a project that is. So I am in no way throwing any shade at them at all. They are, for the limited resources they have, they are doing an incredible job. I just prefer Cargo. It's like, and that's probably because it's standing on the shoulders of giants. Rust is a newer language. It's being able to see, how dependency management has been done in all of the different things, not just PyPI, but like NPM and gems and all of the other languages. They've all got some kind of package management. Even not just languages. We've got apt-get, and we've got like brew, and we've got all yum, and we've got like all of the different ones for all of the different operating systems. And there's a lot of different package managers out there, and Cargo, in my opinion, has taken kind of the best bits in their approach to it. And that's kind of like the first step in the tooling of it. And everything is like Rust Analyzer. This little thing that's sitting down here that most of the time, it's gonna be an error in a minute. Most of the time I don't even notice it's there. It just happily chugs along. And like one of the things I don't like is that we do have compile time with Rust, and especially working with Substrate. Whenever you're building out a blockchain node, like, it can take a while. Running a Cargo build on my current project is probably going to take like a couple of minutes, 90 seconds, 2 minutes, whatever. And so I don't tend to run it as often. Like, I'm used, when I was working in web application development, Python and stuff, I would be saving constantly, and I would probably have like, live reload running in the background that, as I saved, would be automatically refreshing my project, whatever I was looking at. And I don't have that here because it takes like a minute or 2 for it to reload. So instead, I can end up like writing hundreds of lines, and that's pretty freaking unheard of, like, in codes, to be honest, to write like, a few hundred lines of something and then try and run it, and it just freaking works. Like compiles first time and just runs. And that might not seem like a big deal for a lot of people, but like, if you've been a developer for a while, that's pretty rare that you're not gonna be missing a semicolon, or you're not gonna have like some kind of little, it's probably not going to be a big thing that you're missing. It probably is that you just typoed something, or you missed a semicolon, or like, you've got you forgot to specify a type or the wrong type or whatever else. Some of these minor errors that you're slap your hand, fix. But because of Rust Analyzer, and because of the type system, and because of all of the linting and things are happening automatically. I didn't have to configure any of this. This is the most impressive part for me, is I just installed Rust Analyzer. I did nothing beyond that. Like, if I'm setting up Prettier, if I'm setting up like Black, if I'm setting up Flake 8, if I'm setting up any of these other linting or formatting tools for like any other language that I work in, there's a bunch of configuration. But for Flake 8, I have 34 plugins that I install for my linting. I've got to do in every project. I didn't have to do any of that here. Like, the tooling is just superb. Before we get into like all of the language features and, type safety, and like, yeah, everybody's heard all of that stuff about Rust before. But for me, it's the tooling. Like, it's invisible. That just freaking works. And I don't want to have to think about my tools. I just want them to just do the job, get out of the way, and let me be productive. And that's what Rust has been for me so far. So, okay, so yeah, what's special about Rust? Hopefully that answered that question. What else we got going on? What about multi-sig that wants to have many projects? Couldn't you just reserve the funds needed for each project? Yeah, probably. To be honest, like we could have a single multi-sig account that has multiple projects attached to it, and we've got like named reserves, because that's we did bring in the currency system earlier on in the last one, that we're going to have this named reserve currency. So we will be able to reserve currency for each of the milestones, and probably we'll name it after the milestone or something, so we know why it's being reserved. So yeah, there's nothing preventing us from having a multi-sig that could have many projects, and in fact we could use like a storage double map in this instance, so we could have the first key. So storage double map allows you to have two keys for a storage item. So we could have one key, which would be the coffer, so the multi-sig account for the project, and we could have a second key that would be like the project ID, some kind of like hash, something to represent the actual project itself. And then that wouldn't be as intensive to find the correct milestone, because for any of these, we're going to have a bunch of different iterators. So let's look at the different iterators we have here. So we got iterable storage map, iterable storage double map. Let's go look at that one. Okay, so we have like our regular kind of iterator that allow us to iterate over all of the items in a storage. But we should have as well. Is it going to be in this one? What's this we're looking at? This is our frame support storage, iterable storage double map. Iter prefix. Here we go. That's what I was looking for. Okay, so they enumerate all elements in the map with the first key K1 in lexicographical order of the encoded key. So if we think that our K1, our key one, would be the multi-sig, then this would allow us to iterate over all of the projects belonging to a single multi-sig account. So hopefully in that instance, we wouldn't have a single multi-sig that's going to have a ridiculous number of projects attached to it. We'd be able to like get from a milestone back to a project pretty quickly by just like iterating over all of the ones associated with that multi-sig, then looking at the milestones collection that we have on the project, this thing here, and seeing if it contains the correct hash, that within that collection. And that probably would be fine. It's not going to add an awful lot more overhead to it. And that definitely is a way we could go about it. Should we go about it that way? What do we think? Anybody got any major inclinations either way? I might do it just because I've not used this iter prefix before. Might be a good excuse for me to give that a try. What do we think? Should I? Yeah, we should. Oh, also for anybody who's wondering what lexicographical is, think of like alphabetical, but for things that are not just letters. So if you're thinking ordering stuff that maybe numbers and letters or special characters or anything, alphabetical is just like A to Z. We say alphabetical a lot of times, and then we also include numbers in there, like 0 to 9 and A to Z. I'm gonna go, we're gonna organize in alphabetical order. We can't organize 0 to 9 alphabetical order, strictly speaking, because they're not part of the alphabet. So what we're actually referring to there is lexicographical order, and this is what this is talking about. It's like dictionary-based order, and this is a really important thing to be aware of as well. So whenever you're putting stuff into storage, say, you're putting in like 3 numbers, let's just look at this here. So, so you've got 3 storage items that you're putting in, and they have keys of 1, 2, and 3. Okay. So you would expect that when you put these into storage, and then, it's cool to see you've done with multi-sig. So I'm going to take you up in a super fun surf. We're going to not link them. We're not going to limit it to 1 project per multi-sig account. We're going to let them have as many projects as they wish, and we'll use a storage double map for it. But yeah, ordering stuff in storages. So if we think of, we've got storage keys of like 1, 2, 3, and we then trying to iterate over those keys, you know, so we use like one of our iter functions here, like our iter prefix, or, you know, just a regular iter. You'd expect it maybe to come out in that order. You know, it says here, comes out lexicographic order. So you'd expect, okay, I have things with keys 1, 2, 3. If I iterate over them in lexicographical order, they'll come out 1, 2, 3. They won't. They will come out in this order. So you think, oh, is it coming out in reverse order? No, because if we had keys 1, 2, 3, 6, and 8, the order that those will come out in is 3, 8, 6. No, sorry, 3, 2, 8, 6, 1. Anyone hazard a guess why it looks like it comes out in some random order and we're saying it's going to come out in lexicographical order? Because it's the encoded key. So we talked about earlier, like scale encoding and whatever we are putting a key into storage, obviously we create like a hash off the key. There's different hashes and things we use. There's just different prefixes that get added to the key depending upon like what the palette is and what the name of the storage is, and you know, there's a whole bunch of stuff to go into how we work out what the actual key is. But it's the fact that it is the encoded key that it is ordered by is the important part here. So I just happen to know that whenever you encode these values, that the order that of the encoded representation of each of these is going to be that order. Don't ask me how I know that. I've been doing a lot of work with storages recently. That I fucking know the order of encoded values of keys should be like what for probably 1 to 10. Yeah, that is not something you will ever need to know to work in Frame. I just wanted to point out that if you are trying to iterate over things that are in a storage and it appears to be coming out in a random order, it's not a random order. They are ordered, but they're ordered by the encoded value of your keys, not by the input value, you know, so not by the decoded value. So something really to kind of bear in mind for those is you can never assume that the values are going to come out in the order you put them in. Okay. That's just a simple way of thinking about it. But yeah, so back to this, we have iterators that will do our prefix, and a prefix will allow us to do like this lexicographic order on our first key. So we can do this then where we're still going to need this. Okay, we're still going to need to know what the multi-sig account is for our milestone. But then we're not going to be able to like just pull out the one project unless we also give it a project ID as well. No, we'll just iterate over it. If I was probably doing this production, I probably would give it the actual project ID too, if I'm being 100% honest, but I kind of just want to use this iterator. We can refactor it later. So still going to give it that. So I'm going to iterate over the prefix. This is going to be our prefix, and then we'll be able to find the milestone that way. So that means that our storage is going to have to change slightly. So we are using a storage map here. And now we're going to change this to use a storage double map. And the storage double map is going to take a couple different things. It's going to take let's work through these in order. This first thing here, where I'm just saying, you know, infer the type. These are all like the different types, by the way. This first thing where I'm saying infer the type, that is our prefix. I'm not going to change the prefix. I'm just saying like use as is. And what the prefix is going to be is how the keys are structured. So we're going to provide it with a couple different things here, key wise. You know, we're going to provide it with like our account IDs, etc. But before that part, it also has like the key prefix. And the key prefix is going to be made up of two things. It's going to be an encoded value of the palette name and an encoded value of the storage name. So the prefix for this is going to be like projects underscore projects, but encoded. Okay, that's going to be the prefix. 9 times out of 10, or even more so than that, you're probably going to be fine with that. There's going to be no need to change what the prefix is, but you need to be aware that if for whatever reason I ever need to change the name of this storage, or I ever need to change the name of my palette, it is going to change the storage key. Okay. So if I've got stuff stored on chain and I have to refactor what my palette is called or what my storage name is called, I still need to be able to reference that the previous values I've stored. I'm going to want to change this. Okay. I'm going to need to like pass in a custom prefix so I can still reference those values. Probably the only time you're ever going to want to need to pass in your own prefix, but it is available to do so if you need to. One thing I can't seem to find anywhere is Polkadot burned sometimes. Again, not really want to talk an awful lot about dot here, but yes, yeah, there is circumstances where it is. I'm just going to bring this up because we are launching the new governance. Let me see if I can find URL for it. Treasury proposals. If we're not aware of like treasury proposals and things, this is how you can get stuff funded within kind of Polkadot. You know, so you can make proposals to the treasury for things you would like funding to do. You know, so switch to governance v1. Is it live? Oh, yeah. So here we have like a list of proposals. You know, so we've got like different ones here for like doing different things. There's a forced transfer here that's being proposed. We've got like Unbrick the Zeitgeist Parachain, you know, so all different proposals go through here, not just for funding, but like anything really that wants to happen. We've got treasury proposals though, are the ones that are looking for funding. So we've got an ink design security review by Open Zeppelin here. So they've put through a proposal. So they, given the successful completion of Open Zeppelin's security review of the Ink smart contract language and Substrate smart contracts palette, this community proposal is for a second installment supporting Open Zeppelin's work. You know, so they are, you can go here, you can read the full proposal, etc. And they have requested 24,108 dot for this proposal. It's currently proposed, you know, so let's get timeline here, etc., etc. So this is like, you make proposals for things that are going to be benefit the ecosystem, etc. And that goes to the treasury. Back to your question about like burned. So there we go. So currently, we are looking at, and a spend period is essentially a month, I think. So we are currently set that if we do not spend this dot, so this dot is not assigned to treasury proposals within that time, then it is burnt. You know, so yes, to answer your question, dot does get burnt sometimes. This is one of the situations that I'm aware of in which dot gets burnt, is if we do not meet if we do not spend enough on treasury proposals in each spend period, then whatever's left is burnt. So get your proposals in, folks. You know, there's plenty of dot up to ground. So look at, it's asking, what do we see the Polkadot can do in 5 years? Well, if you look at just like the last year, for example, you know, so we launched parachains a little over a year ago now. And let's go take a look and see where we are with those. The 190 projects currently parachains.info. I think out of those on Polkadot that are currently like parachains, does it give me a total here? I think there's like 40 something, 43. Come on, how good was that? I knew that off the top of my head. So in a little over a year, since launching parachains, we have 43 parachains that are now currently live on Polkadot itself. Let's have a look at Kusama. There's another like almost 40 on Kusama as well. Some of those obviously will be canary networks for other parachains, etc. And we have total 190 projects that are currently kind of either proposed or in some kind of state, or looking for crowd loans, etc., etc. And that's in like just year one, you know. So, and yes, we currently you know, we're in a bear market, etc. All of the blockchains are currently seeing a downturn in active developers, all that kind of stuff, you know. So this has not been the greatest timing for launching this kind of stuff, you know, during what is a kind of downturn in the industry. And we still have 40 odd projects launched on our relay chain, on our mainnet, and similar on our Canary network. We also have only recently started teams like this team, you know, like developer relations. We've only, as I said, we've done just 2 cohorts of Polkadot Blockchain Academy. You know, we've got the 3rd one coming up in July. Like, we've only really now started to begin. You know, Polkadot obviously our substrate has been in development for the last 5 years. We're now at a point where we have live projects and where you can onboard more parachains, and really the ecosystem can take off from here. You know, so in 1 year we've had 40 projects. I think we can probably better that in the 2nd year, and again in the 3rd year. You know, we're seeing a 3.7 to 4% growth in developers, kind of month over month, et cetera, et cetera, et cetera. So in 5 years, you know, we should have hundreds of projects, specialized L1 blockchains operating on Polkadot. You know, and for me, then that starts to get really friggin' interesting. Like, we're already seeing such cool stuff, you know, for everything from like Zeitgeist to Crust to Kilt, you know, these Star, Moonbeam, you know, really successful projects doing really cool things, very specialized things in some cases as well, that just wouldn't be possible on a different infrastructure. You know, to have something so specialized as some of these parachains are doing, but it offers such a great composability that you can then start building out these unstoppable decentralized applications from all of these like separate parts from all these very specialized chains. And that's where we're getting to now. You know, we've done the groundwork, we've built the infrastructure, we have this fantastic blockchain SDK where we now have the first kind of batch of parachains live. We're hopefully going to keep onboarding more parachains. I'm going to be here to keep teaching people about Frame and how they can write their own blockchains. But we're also now should start seeing as well those L2s. You know, the dApps are being built on top of these parachains. You know, they're composing themselves out of these very specialized functionality they have. And I think we're going to see some really cool things that just were not possible before being built out of these. So I'm very excited to see what I can do in 5 years. And you know, I'll still be here in 5 years. I might not be working with Parity, because that's really another interesting thing, is because of this, you know, because of on-chain governance, we want to try and move as much as we can on the chain, you know. So Parity might not be here, might not be a need for it to be here. You know, hopefully it's going to be all managed by the ecosystem. You know, like we'll have a developer education and community fellowship, like we have a technical fellowship, and they'll be managing stuff like this, like running our education initiatives, or doing streaming, or writing tutorials, or giving conference talks, or running events, or all of that kind of stuff. And the Blockchain Academy, it's spinning off into its own org as well. It's going to be all done on chain, you know. So it is a very exciting time for me as a developer to be part of this ecosystem. Like, I think it's just going to keep getting better and better from here. You know, there's been so much work done to lay an incredible foundation with probably the most interesting tech in the entire industry. Like, yeah. I know I'm waxing very lyrical now. Sound like some kind of preacher over here. But no, I wouldn't be here if I didn't believe that, you know. It's difficult to do my job in a technology that you're not infused by, you're not enthusiastic over. So I'm very enthusiastic about this. Right, where did we get to with our iterable storage stuff? Okay, we were talking about like lexicographical order. We did that. And oh yeah. We were modifying our storage double map. So we talked about prefixes. We know those for. Okay, hashers. So I'm going to be using Blake2128 concat. It's probably a default hasher that you should use pretty much anytime you need to be like hashing a value for a key for storage. And there's really a couple of reasons for that. So we have three. Actually, we have five, but two of them are going away. So let's not talk about those. We have three hashers that you can use for your keys, or that we provide. You can probably use whatever hashes you want beyond those, but three that we provide. Blake2128 concat. We also have I can't remember what it's called. It's in here somewhere. Hashing algorithms. Okay, yeah. 2x64. It was like 2x something, but I can't remember. Is it 12864? 64. Okay, 2x 64 concat and identity. And you notice that the only one that has an X under cryptographic is this Blake2128 concat. And the reason why having a cryptographic hash is so important when you're thinking about keys is for pre-image attacks. So keys are stored in a Patricia tree, whichever you pronounce it. And essentially you need the keys to be equally distributed, you know, so the characters within the keys need to be random, and they need to be an equal distribution of random characters, because otherwise what you could end up is if you've got a lot of keys that share the same starting characters, is you end up with a tree that's very unbalanced, you know, that it's all of your keys are kind of going down the left hand side or whatever, and then you end up having to do multiple hops. I don't know if people are very familiar with this. We'll look one up here. Okay, so Patricia tribe, Patricia tree, whichever you want to pronounce it. These are our different keys to the side, and you can see here, like, okay, so they all start with R, so that's like our root, and then they split, you know, OM, UB. So OMs go down the left-hand side, UB goes down the right-hand side, and then we've got like, okay, so AN is one thing that's shared between these, ULS is another thing, so like splits to AN, you know, so we can see how this is kind of balanced here, you know, by being able to split on these shared characters, we end up with something that's roughly kind of balanced. If you imagine that somebody was able to provide a pre-image that meant that all of these had very similar shared characters, then we could start to construct a tree that is not so balanced, that is all going down this ROM, AN, and just keep splitting, you know, multiple little hops all the way down. And they don't have a lot of like kind of shared or they all actually do have a lot of the shared first characters, and then, you know, keep splitting off, so it's all going down like the left hand side or the right hand side, and we get this unbalanced tree, and then we end up with like more hops than we normally would have. That makes it less efficient to look things up in storage, and now we're at the point where, you know, we have a possible attack vector where somebody could cause a degradation of service in our chain if they know how to provide a pre-image that's going to be encoded in such a way that allows them to create an unbalanced tree. So we need a cryptographically secure hasher. Blake128. Okay, it's cryptographic, so it's going to ensure that we have a random distribution of characters within our keys. 2x64 is not cryptographic. It's faster, so, you know, there may be instances where, for example, the user's not providing you with the value that you want to hash. You know, you know that the value is like an integer or something that you control. Maybe it's the block height, for example, and so that's not coming from the user. That there's not going to be a pre-image attack on it. That's just going to be this incrementing U64. Then you probably could get away with using 2x, and 2x is slightly faster. Okay, not a huge speed difference, slightly faster. Identity is the one you got to be very careful with. Identity does not do any hashing. Identity takes whatever input you give it and makes that the output. So that is only if you already have hashed something and you have hashed it, not that you said to the user, hey, hash this first and then send it to me. Like, you have already hashed whatever the value is. That it is cryptographically secure, whatever. It's not going to cause an unbalanced tree. Then you can use the identity. Okay, so you don't need to like rehash something that's already been hashed. But it should only be if you yourself in your code have already hashed the value previously. Okay, it's not coming from a user. You're not saying that the user has to provide you with a hash. You know that it has been hashed. Then you can use the identity hasher. But in majority of cases, you're going to want to use the Blake 2. The speed increase you get from the 2x, probably not worth the security trade-off, in my personal opinion. Your mileage may vary. You may have different opinions about that. I would rather take the minor hit in execution time to use Blake 2 than be concerned that there isn't a vector, attack vector I have not considered by using 2x. So that's probably like some imposter syndrome I have there in my own ability to identify what attack vectors are. But I'm a pretty defensive programmer, so I'm going to use Blake 2 pretty much all the time. Like, it's very rare you see me not use Blake 2. The concat part of it here is why there's all marked as transparent. It's also why I said that we have 5, sort of, but we only really have 3. It's because we also have Blake 2, 128, 2x64 without the concat version, just the regular versions. And what we mean by transparent is what it actually does is it hashes it. So we've got like, you get your input going into the hasher, and then you've got like your output coming out of the hasher. It concats together the output and the input. So we still have a random distribution of characters for our keys, so we don't get unbalanced trees, etc. But we also have the unencoded value as well. So that helps with things like being able to do different kinds of iterators and stuff. Okay, so that's why we always recommend you have this concat. It'll concat together the inputs and the outputs, and then it's used a lot internally within Substrate for doing different kinds of iterators. So much so that I don't even think that I think the non-concatenated ones, like the regular ones, are still available, but they're not like inner documentation stuff anymore. I wouldn't recommend you use them. If you use them in a situation where you want to use some of the built-in iterators, it may not work. Okay, or it might give you results you're not expecting. So just use the concat. It's not gonna make a big difference for it. So that is our hashers. Okay, so we got a storage delta map. So the first one we're going to do is as we talked about was earlier with Superfund Surf, is we're going to have this be our multisig. So this account ID here is going to be the account ID of our multisig account of this coffer. And then we probably want to have our second key in it is going to be some identifier for the project itself. Title. Can we say that titles have to be unique? Could that be a thing? No. Let's make them give us a hash as well. Some kind of ID for it. So we just said here, let's do this similar for our project hash. And that's just going to be there we go. Okay, so they're going to have to supply this to us, some kind of like unique identifier for the project. I'll pop this in here. Oh, go away. There we go. Oh, that's not what I wanted at all. So, project hash, we got milestone hash. We need to add this into our project. Then that we're going to. Do we need to store it, or do we need to just set it as the key? We wouldn't need to store it. It's just going to be the key for it. Yeah. Yeah, we didn't store it. It's just, it's just going to be the key. That's fine. So we're going to go in here. We're going to do, again, Even though we're saying supply us a hash, we're not going to trust them. We're going to use our hasher. And this is going to be a project hash. Alrighty, so there is our first storage. Storing our projects. It's going to be a storage double map. Our two keys are going to be the account ID of the multisig and some form of ID for the project itself, and then the actual project that we're storing. So that's our first one. Then we can do our next one, which is going to be for our milestone. And what is our milestone? We set up here because we put this into our project, don't we? That's going to be the milestone hash. So yeah, again, we don't even need to really store this on here. It doesn't need to know its own hash because it's going to be the key. Take that out. Take that as well. So we could actually generate these for the user. We don't need to request them off them. We can create these for them. So that's fine. So it's going to be there. And this time we're just going to make it storage map. I don't think it needs to be a double map. That's it. What are two keys if it's a double map? So in this instance, it's gonna be stored under that hash that's provided, the ID for the milestone. Could be possible that a user provides us with the same ID. So yeah, let's make them unique per project as well. So we're gonna do another double map. This milestone is gonna have to be added by the multisig. So we can do the same as we're doing here. We're going to do our hasher, and the first key is going to be the multisig account. So they're all, they can only be created by that multisig account, and they can only add them into the storage. Because what we don't want to have is somebody creating another milestone, giving it the same ID as a milestone of a different project, and getting overwritten in storage. So yeah, that makes sense. And then we're going to give it another blank to 128 concats or hasher. And this time it's going to be our milestone hash. And we're going to store our milestone. Generic T. Well, what are you shouting at me for? What have I done wrong? Oh, previous definition of the type. Oh, okay. So this needs to be milestones because we have a milestone struct. So our storage needs to have a different name. So milestones stores a collection of milestone, and projects stores our collection of project. Okay, cool. So what are you shouting at me for? We got a prefix, key one, hasher key one, hasher key two. Those were all fine. Oh, okay. Just I was getting ahead of myself there. I was just giving a red squiggly while it caught up. That's okay. Okay, so we got our two storages. What would we work on next? Probably actually next up is going to be our events and our errors. So I like to kind of have a few of these ready before I start writing my collections. And our events and our errors are pretty important. Actually, let's commit this here. What we got going on here? Okay, so we are going to get the palettes, projects, source types. Okay, and yes, we want our cargo lock, we want our toml, we want our actual lib, and we want the updates to our runtime as well. Yep, that's fine. Everything. That is, yes, it is. Okay, so now I can just do what we're gonna call this. This is our add project or add palette storage structures. Cool. Okay, so let's have a look at our log. Because what I actually want to do is let's come back to this one. So I can show you what. Oh, what these events and stuff are. Okay, so we have. Oh, go away, go away, go away. So we now, oh, it's gone right back to being called template again. That's why. So, okay, in here, this is like the default substrate node template. This is like, I've gone back to the very initial commit. And this is just like what you get as soon as you pull it down. And what it has in here is it's got an event and it's got some errors. Okay. So our event is just like something stored. And we've got a couple of errors. We've got a none value error and a storage overflow error. And I'm going to show you how once this compiles, what these are actually for. So whenever you are working in like your extrinsics here and your calls, they can deposit events. They can emit an event. They also can return an error as well, and we'll see that in a second too. But these events are pretty important because it's like how you notify people that something has happened on in this transaction within this extrinsic. So come on, this was something earlier for people who were like on the stream earlier on when I was talking about how I don't really compile my node very often, that I sometimes can write hundreds of lines of code in between kind of compiles. This is why, because it takes a little minute to compile. You know, it takes maybe sometimes more than a couple of minutes, and that's not unreasonable when you think of what this is actually doing. Like this is a full blockchain node with a runtime, custom palettes, all that kind of stuff. Like it's an impressive piece of tech that we are building here on my local Mac. You know, this is not some supercomputer or something running on a server farm somewhere. This is like walk into your local Apple store and buy 2 years ago Mac. You know, I mean not 2 years ago, a year ago. It's an M1. Whenever they M1 like Pros, Max, whatever it is, whenever they came out, you know, that kind of old Mac, kind of like level Mac, and it still builds pretty quickly. I think my Air actually builds it faster, if I'm being honest, the M2 chip. But yeah, that built okay. And we can see now we've got our node running. And if I go to JS, and we go into our apps here, I can connect my local node, which it already is. Let's just double check here. So we've got 6 and 7, last block, 7, new block, 8. Okay, great. So this is connected to my local node. We can see the chain state here. And I can go and I can run some of these extrinsics. So it's template module. Right. So look at this cause error one first. So this is this method here, this extrinsic. And what it's going to do is it's going to see if there is something stored. You know, it's going to do a get on that storage of something. If there is nothing currently stored, then it's going to return this error. Okay, so we can see the dispatch result is what's being returned from our method call here. And dispatch result can either be okay or it can be error. So we're going to return an error. We're going to return this non-value error, which is defined here. And let's see what happens whenever I do that. So we're going to do cause error. I've not got anything in storage yet. And we're going to get a little red. Okay, extrinsic field, and here is that. I'm going to look at the Explorer. Let's look at the probably that block. Extrinsic field. Okay, so that we can see that is like part of the events that have happened within that block authoring. Now, if we go and we do the other extrinsic, so we're going to go back to template module. We're going to go do something which stores a value. We're going to store 10. Submit transaction, sign and submit. Okay, this time it's worked. You know, we've got this do something, and we've got extrinsic success. If we go back to Explorer, we can see here recent events. We can have a look at that. And we can see our extrinsic success. Okay, and we can see, you know, here is our other event, something stored. So if we go look at our events here, we have this something stored event, and it takes something, so what was stored, and who, which is the account that that called the origin of our call here. Okay, that's this who. And those are part of what's emitted. So we can see here, yep, there's our something, and there's our who, which was the account that I signed it with, which is one of the test accounts. We go, yeah, Bob. Okay. Let's just do another one for Bob here. Or let's switch to Alice. And we're going to do something, and Alice is going to store 99. We go look, explore, we got our something 99 by Alice. Okay. So these are the events. So a lot of times you'll see that these events are emitted on like the end of extrinsic, so here just before we get to our okay, we're depositing this event of like something stored. It doesn't need to just be for that. It really can be, whenever something you think another party may be interested in. So I have ones where, a single extrinsic can emit multiple different events, depending upon what's happening within that particular call. You might want to have one at the end, that says like, here is a summary of what occurred within this extrinsic. We also might want to emit events, like if you're looping over something and performing some action, you can emit an event for every iteration of that loop. There's nothing preventing you from doing so. And then errors are, as it sounds, anytime extrinsic is going to not complete the dispatch result is going to return an error, then it can be any one of these. So I think in our next stream, so next week, we'll look at what our happy paths could be, like what events that we should emit, and also what our error conditions could be. So things like trying to add a milestone to a project that doesn't exist, or trying to add a milestone to a project that doesn't have enough unreserved funds to pay for it. That kind of idea will be like our different error conditions. And then we'll have like, some of our other events, which could be like milestone created or, status updated or any of those kind of stuff. So I like to kind of try and think about what my different pathways could be and what kind of events I want to emit or what my possible error conditions could be, and write all those first, just to, kind of help me structure what I think is going to happen within my palette. Also, a thing to note is if one of your extrinsics does return an error, so actually let's just do that. Let's try that. This will be the last thing we do, and then we'll call it today. But let's say we're going to put something into storage. What are we going to put into storage? Let's just put, this is going to be a U32. Let's put 90 into storage. Okay. So we're going to save that. Now, yeah. No, because at this point, this is going to get, and it's going to return true. So let's, we're going to put this, so this gets called, and this still returns false. Can I just do match none? Can I do that? Is that going to work? No. Because it's thinking it's matching on a, okay, yeah, let's just do, let foo equal option. Is that gonna work? And if I do match on foo, it's gonna be like, no, you can't do that. Yeah, of course you can't do that, Aaron, because it's like wrong kind of thing. Let's just create another storage. Right. What I'm trying to show here is that if we exit out of an extrinsic, that it's not going to store. It's not going to record what we were doing. So we're going to do another something in here, which is going to be the exact same as that. Let's, and yeah, of course that wasn't going to work. We try to like, all right, there we go. And in this one, instead, we're going to do another something. I'm just going to put that 90 in there. Okay. Right. So now we have two storages. We have something and another something. They're both just like storing numbers. We're going to rebuild. This is going to take a couple of minutes. And what I'm hoping to show is like, so this is, every time we call this extrinsic, it should be putting this value in here. Okay. Like that's getting called straight away before we do anything else. Before we run this get, before we return an error, before we're doing okay, we are doing a put. of this value into this storage. However, if our extrinsic, so if this method returns an error, it should not perform this action. We're going to find out if that's true or not in just a second. But these are in a transaction layer. Okay, so there's different layers in storages of where things occur. You've got their actual like database. Then you have a layer above that, which is essentially a cache layer. There's different terminology for it, but it's essentially a cache layer. And then you have your transaction layer. You can have multiple transaction layers. You have a transaction layer per extrinsic that you're running. And these transaction layers, all of the actions will happen within that layer. And it's only at the end of the extrinsic, only whenever this returns are okay, will anything that's incurred in that transaction layer, will that status change be written back up to layer above it. And what that means as well is, if we have something going on in here where like I'm lifting a value out, I'm making a change to it, I'm putting it back in, I'm lifting it back out again, I'm making another change, I'm performing multiple reads and writes on the same value. And then I come to the end of my extrinsic and I'm writing it back into the database. It won't actually perform all of those actions. Okay. It's not going to like do them all in order. It's not going to look at like, okay, so we read out a value of 10 and then we added 2 to it and then we put that back into the database and we read out the same value again. It's now 12 and we divided that by 2 and wrote it back in again. And we lifted out that value of 6 and we added 3 and wrote it back in again. And then we lifted out that value of 9 and we added 1 to it. We put it back in again. At the end of that extrinsic, it's going to be like, oh, so we started and our value in our database was 10 and the value in the database is now 10. There's no state change. So it's not going to actually do anything. We don't have all those read and writes. Those are all happening in a transaction layer. It's not going to replay them against the database. Instead, it's just going to look at what the state change was, that it went from 10 to 10. There's no state change. There's nothing to save. Okay, cool. So this is running again. Let's just try to refresh here. Okay, so we're now connected to 8. Let's go to our extrinsics. We're going to call that cause error one. Actually, no, let's look at our chain state first of all. So we got this never something. Okay, there is nothing stored in there, right? If we now go to our extrinsics and we call this cause error, now our code, it should be putting this value in there. We submit it. Okay, so we have a non-value. So it's raised an error. We could look at our chain state. Fingers crossed, because there's an error in our transaction, it shouldn't have actually saved anything. Okay. So glad that worked. That's a really nice way to finish the stream. So yeah, so because there was our transaction here, because our extrinsic returned an error, then that transaction layer where this state change occurred was just thrown away. It's not actually persisted. Okay, so something to bear in mind is if you're thinking of like regular databases and you've got like ACID transactions and things, and you got to think about like rollbacks or that kind of stuff, you don't need to worry about those here. Okay, you can perform whatever actions you want, and if one of them later on doesn't meet a requirement, or it's for whatever reason you need to not save the previous transactions, you just return an error, and nothing that's occurred in that transaction layer will actually be written in the database. So that's a really, really handy kind of thing to have in it, and a really good thing to kind of bear in mind is you don't need to worry about rollbacks or like setting the state back to what it was if something occurs later on in the logic of your extrinsic that means that you don't want to make the previous database changes. Just return an error, and none of the state changes that happened in that extrinsic will actually be persisted. So that is everything for me for today. I think we got to a pretty good spot there. As I said, next week we're going to be looking at our events. We're going to be looking at emitting events. We're going to be looking at errors. We'll start probably writing our first extrinsic so we can start interacting with it with Polkadot.js. But yeah, I've again had such a good time. Thank you so much, chat, for the questions. I always appreciate those. I'm really looking forward to, sounds like we're going to see some of you at PBA, at Polkadot Blockchain Academy. So that's going to be super fun. Please do come up and let me know what your username is in chat. Unless you actually do go by Snowmead at PBA, and you do look like, I don't know, some kind of Viking, maybe? Like, if that's what you look like in person, awesome. Like, I can't wait to meet you. But otherwise, please do come up and go, hey, I'm Snowmeat. Otherwise, I'm not going to know. But yeah, thanks again, everybody, for joining me today. And I will see you all same time next week. Have a wonderful rest of your day and a good weekend.